Now we're going to use a lot of what we just saw with the next section on solving a right triangle. And when you see the directions to solve a right triangle, and eventually later on in this course, we're going to be solving triangles that are not right triangles. We'll be solving any kind of a triangle. But we're going to specify solving right triangles at the moment. To solve a right triangle simply means you got to come up with all of the missing sides and angles that they're not giving you. Okay? They're going to give you a couple parts and pieces of this triangle. Your job is to use your trig functions to come up with, or maybe even also the Pythagorean theorem, right? You can use that as well with a right triangle. Come up with all the other missing parts and pieces that you don't know. I want to also point out practically all math books, when you want to label a triangle, you use capital letters for the vertices, the points of the triangle, and you always label the side across from the capital letter lowercase letter. So side B will always be across from angle B. Side C will always be across from angle C, and side A will always be across from angle A. Always. So here's an example where they're giving you right triangle ABC. They're giving you information about angle A. They're telling you that it's 34 degrees, 30 minutes. And they're telling you that side C is 12.7 units, in this case inches. Come up with all the missing other sides and angles. Now right away, let's go ahead and change our degrees and minutes into a decimal equivalent. We all know that 30 minutes, right, is 0.5 of a degree. So let's go ahead and just say that angle A is 34.5 degrees. I like working with decimal degrees than I do minutes and seconds. So 34.5 I'm going to think of right here. Angle A is 34.5. Well, we already know angle C is 90, so let's go ahead and find angle B. Angle B is found by taking two ways of looking at it. You can take 180 degrees minus 90 minus 34.5, or another way of looking at it is that angle A and B, right, have to be complementary. They have to add up to be 90. So we can simply take 90 degrees, subtract off 34.5 degrees, and get 55.5 degrees. So angle B, we now know 55.5. I got all three angles. I got one of the sides. Now I need to come up with the other two sides. Let's start with side A, little a. What trig function, and there are more than one correct answer that we could use here, but what trig function would I use to try to come up with A using maybe an angle that I know and the side that I know, side C? How could I get little a using one of our trig functions? I want to make sure that the trig function that I use captures the side that I'm looking for, but again also uses a lot of the other parts and pieces that I already know. So do you see, if I use the sine of 34.5 degrees, the sine of that angle is opposite side A over hypotenuse C that I know, right? C is 12.7. And now if I think of what I have as a proportion, the sine of 34.5, I can think of that as being over 1. And when I need to solve a proportion, right, we cross multiply, and when I cross multiply, little a is the same thing as 12.7 times the sine of 34.5. So calculator, what is 12.7 times the sine of 34.5? And I'm assuming since C is right, C is given to us in tenths. Let's go ahead and round this to the nearest tenth, 7.19. So little a approximately equal to 7.19. So there's a missing side that I got. There's a missing angle that I got. And the only other thing to find now would be side little b. And this is entirely up to you. Now that you have A, little a, side A, and side C, if you want to, you can use the Pythagorean theorem now, right? C squared equals A squared plus B squared. You could go that route. Or you could do something very, very similar to what we did here, using whatever angle that you'd like to use. You have choices. A couple different ways, right, that you could come up with side B. You could say that the sine of 55.5 equals opposite side B over hypotenuse 12.7 of one way of getting your solution. What else could you have used? You could say cosine of 34.5 equals adjacent side B over hypotenuse 12.7. And now that you've already figured out little a, you have a third choice. You could say the tangent of, let's say, 34.5 equals opposite side A, which you now know, 7.19 over B, which is what you're looking for. So you have choices. Pythagorean theorem, one of these, doesn't matter to me. If done correctly, we'll all end up with the same solution. So let's go with the sine of 55.5 equals B over 12.7. Again, you cross multiply. We'll get that B is equal to 12.7 times the sine of 55.5. And that's approximately equal to 12.7 times the sine of 55.5, 10.5, approximately equal to 10.5. So those are your missing parts to that right triangle. Okay? Questions so far? I'm going to have you guys try this one. All right, let's start with, you have the choice right now. If you wanted to, you could come up with B really quick. You could use Pythagorean theorem. You could say B squared equals C squared minus A squared. Do that algebra arithmetic, and you come up with B that way. So we got to come up, our goal is to come up with B and also come up with angle A and also angle B, which if we get angle A or B first, we can always get the other one by subtracting off of 90, right? Because they're going to be complementary to one another. So what trig function, guys, could I use with angle A that would also use the 29.43 side A and side C? Sine. So we're going to say that the sine of A equals 29.43 over hypotenuse 53.58. And again, I'm asking the calculator, what angle has a sine of this ratio? So we'll say calculator, inverse sine of, and I'm going to simply enter that fraction in as I see it, 29.43 divided by 53.58. And again, the calculator will always give you quadrant 1 solutions, which is accurate here because we're using a right triangle, which we're always going to get angles between 0 and 90 degrees. So we get 33. Let's round that off to 2 decimal places. Let's say 33.32 degrees. 33.32. There's angle A. Actually, I'll write it over here. 33.32 degrees. And now we can quickly come up with angle B. Angles A and B are complements of one another. So 90 minus 33.32, 56.68. 56.68. Only thing left to do now is find, excuse me, side B. Again, you have all kinds of choices. Now that you have these two angles, we can say that the sine of B, which we now know, the sine of 56.68 equals little b, which is what we're after, over hypotenuse 53.58. So we cross multiply again. Lowercase b, or side b, is equal to 53.58 times the sine of 56.68 degrees, and 53.58 times the sine of that angle, 56.68, 44.77. So those are my three missing pieces. Not too bad. Guys got any questions? Again, once you start finding a couple things, then your choices open up to the way you'd like to tackle the problem. All right. Now, what else can I add to these types of solve triangle problems? And as you'll see in the syllabus, and if you leaf ahead to the next section, you'll see that the word problems that we're going to run into will become more involved. But we're going to have to come up with ways of solving, right? So we're covering the basics of solving right triangles right now. But the word problems in the next section will require us to solve some type of right triangle to answer the question that they're referring to. Some vocabulary that I will throw out at you. If you hear the words angle of elevation or angle of depression, one simply means angle of elevation. Simply think of it as you're standing on the ground and you're looking straight across. You're looking parallel with the ground that you're standing on, and then you have to look up at something. And think of it that way. Here's you at point X standing on the ground. So you're looking across parallel with whatever you're standing on, that plane. And then you have to look up at like a balloon or a kite. And that angle that's involved we call an angle of elevation. Versus you're up here flying a plane. That's a plane. And you're looking again parallel with the ground, but then there's some kind of dog, and you have to look down at it. So actually I like to label it this way. You're actually looking across parallel with the ground, but you have to look down at something. We call that an angle of depression. All right?
Why is the dog bigger than the plane?
Dog's bigger than the plane, so that's why we're going to fly over it and keep on going. So here's an example. It says Shelley knows that when she stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If her eyes are 2.3 feet above the ground, find the height of the flagpole. So part of the flagpole is missing, or it's not showing up very well. Let's draw the actual flag, the mast itself, to the ground. So you're trying to come up with what is the full height of the flagpole, which is side A. But please make note that side A doesn't stop here at the right angle. Side A is this whole length here. So our game plan is to find, well, actually I got my, it's labeled wrong. My apologies. Side A does end here. That is side A. We're going to come up with A, and then we're going to add on her eye level height, right, to get the entire height of the flagpole. So we do want to find just A first, and then we're going to add on the 5.3 feet. Now let's change degrees and minutes to decimal degrees. So 40 minutes, right, out of 60 minutes. 4/6, 2/3 is 0.666 repeating. So we're going to change 26 degrees 40 minutes to 26 degrees or 26.67 degrees. So what trig function am I going to use? I really don't have a choice with this problem. What trig function am I going to use that uses that angle and also captures some other information about this problem so I can come up with A? Tangent. I do not know the hypotenuse of that right triangle. And recall our little catchphrase earlier, SOHCAHTOA, that tangent's the only function that does not require the hypotenuse. Sine, I need to know hypotenuse. Cosine, I need to know hypotenuse. And I do not know the length of that hypotenuse, so I got to use tangent. So the tangent of 26.67 degrees equals opposite side A over adjacent side 123. So side A will equal 123 times the tangent of 26.67. So I ask my calculator nicely. What's 123 times the tangent of 26.67? And the value it's giving me is what A would be. So in order to keep the accuracy intact, why round that off and then go ahead and add on? Let's just say calculator right now, take what you're giving me for side A and let's just tack right onto that, add on to that the 5.3 feet, which is how tall Shelley is from the ground to her eyes, and we'll get the overall answer of 67.08. So there's how tall feet that is. There's how tall the flagpole is. Questions or concerns there? So as you can see in some problems, you are forced to use a specific trig function. You just can't pick any one like you could there when we were solving the right triangle. All right, I'm going to have you guys try this one. Okay, we're told that the length of the shadow of a building, the building itself is 34.09 meters tall. The shadow is 37.62 meters. Find the angle of elevation. Simply meaning we're going to come up with how many degrees is angle B. So what trig function am I forced to use again? Tangent. I don't know the hypotenuse of our right triangle. So tangent of B, whatever B is, the tangent of B is opposite side 34.09 divided by adjacent side 37.62. So we'll use the inverse tangent function on our calculator. Second tangent. Asking calculator, what quadrant 1 angle has a tangent of 34.09 divided by 37.62? And calculator says 42.18 degrees. There's your. Excuse me?
It's a shame they didn't ask us the height of the building in that one.
Yeah, read the picture, right? Okay, folks,